What is up, guys? This is Luke Hill for Kit Guru, and today we're looking at a much anticipated product from AMD. The Ryzen 5000G series Cezanne APUs are finally available for desktop DIY builders to purchase. In for testing, we have AMD's Ryzen 7 5700G. This is the new flagship APU that comes in around about $359 MSRP, or around about £310 in the UK. 8 cores, 16 threads, Vega 8 GPU, Zen 3 based. Certainly a lot of things to potentially like, especially with the completely dysfunctional graphics card market at the moment. Perhaps this is a good way to get some reasonable frame rates for just casual gaming without spending silly money on a potato graphics card. So let's take a closer look. Before we do that though, if you like what we do here at Kit Guru, make sure you give us a like and subscribe. You can join the Kit Guru channel on YouTube. Always check out the Kit Guru website, that really helps us out. There's more details over there, and you can follow us through all the usual social media channels. Let's get back into it. Starting out with the CPU side of things, we get 8 cores and 16 threads of Zen 3. This is 3.8 GHz base frequency and up to 4.6 GHz maximum boost clock. As with all Zen 3 products, we get 0.5 megabytes of L2 cache per core. That means you get 4 megs of L2 cache in total for the 8-core 5700G. This time, however, instead of a single CCX 32 meg L3 cache slice that we get with the desktop Ryzen 5000, that's actually halves down to 16 megs of L3 cache for the single CCX design of the Ryzen 7 5700G. That's a notable difference to the desktop Zen 3 parts, and it's probably going to hurt performance quite notably in some scenarios with the Ryzen 5 5600X and Ryzen 7 5800X with 32 megs of L3 cache, so double this one. They could pull away in certain situations. On the GPU side of things, AMD equips the 5700G with 8 compute units clocked up to 2 GHz. That sounds pretty promising initially, until you realise that this is still using the somewhat ancient at this point Vega GPU architecture. No RDNA, no RDNA 2, so not the latest architecture, it's Vega. The same Vega that was being used for the Ryzen 5 3400G 2 years ago, albeit in different form, 8CU form versus 11CU form with lower clock speeds back then. Thankfully though, the GPU does support some useful technologies such as FreeSync and FSR. And then on the SoC side of things, this chip uses a 65 watt TDP and comes bundled with the Wraith Stealth CPU cooler, which at $359 is a bit meager. I think they could have gone for the Wraith Spire, although it doesn't seem to really exist in some of the chips anymore. And the roughly 180 millimeters squared 10.7 billion transistor SoC is fabbed on the TSMC 7nm process. Unlike the desktop counterparts, the APU uses a monolithic die, so you don't have the chiplet and I/O die segregated design like you do with the desktop chips. It's all one lump of silicon here. In essence, this is the same silicon that we see for Ryzen 5000 on the laptop side of things, though there are some subtle differences according to AMD. In terms of PCIe lanes, we get 24, but they're PCIe Gen 3. What? I mean, come on, this is like 2021. Even Intel has Gen 4 now. I see no justification as to why AMD's gone and taken a step backwards when they've got Gen 4 for the rest of the platform on AM4, depending on which motherboard you go for, and Gen 3 on the CPU. Big down point there. And of course, being an AM4 chip, it just drops into typical AM4 motherboards such as X570, B550 with a BIOS update. We get the usual Zen 3 AM4 memory support, and that's really important because obviously the memory frequency and bandwidth directly influences the iGPU performance for this APU. So DDR4 3600 is probably a reasonable go-to. 3800, if you can overclock to 1900 MHz fabric clock, is probably fine. We've seen that with more Zen 3 chips. And if you really want to push your luck, you could try 4 GHz memory and try for a 2 GHz fabric clock, but you do have to watch out there. Anyway, I think that covers the basics for the Ryzen 7 5700G. Let's have a look at some of the test parts and the comparison chips. Our test system uses the Asus ROG Strix B550E gaming motherboard, and this is using the latest BIOS update, which is 2404, with the AGESA 1.2.0.3b profile, which is required for the new APUs. Yeah, try remembering that one on camera. Importantly, we went into the motherboard UEFI and set a 4 gig allocation for VRAM for this APU. For RAM, we've got a 2x16GB dual rank kit of Samsung B-Die Corsair Vengeance LPX. This is 3600 MHz C16, so probably overkill for an APU, but we are talking about a £310 chip, so perhaps not too much overkill. Plus, it will help us isolate performance that we expect from the GPU without any bottlenecks. This is a really, really good kit. Clean power comes from a Seasonic TX1000 1kW titanium rated power supply. Cooling is handled by the 280mm Acertec based Fractal AIO, and we use this cooler rather than the bundled Wraith Stealth because we want to isolate performance on the chip without any thermal induced throttling or drawbacks. And then we add a Gigabyte RTX 3080 eGlow-C graphics card into the mix when looking at gaming performance with a discrete GPU. As always, if you want more details on the test setup and hardware we're using, head on over to the KitGuru website where you can see the written page with extra information. It will be interesting to see how the comparison CPUs compare to the Ryzen 7 5700G configuration. We've got a Core i7 11700K, and that's going to be a particularly notable competitor as a proxy for the Core i7 11700 non-K, especially because it has that Intel UHD 750 graphics. We also want to see how much slower the Ryzen 7 APU is versus the comparable 8-core desktop chip with its full 32 megs of L3 cache and 105 watt TDP. That'll be an interesting comparison, in our opinion. And we also want to see the performance difference for the 6-core but higher L3 cache endowed Ryzen 5 5600X for somebody thinking of going down that route with a cheap discrete GPU. And then I think one of the other comparisons that we want to make and put some emphasis on is versus the Ryzen 5 3400G. Because yes, this is pretty much ancient by CPU standards, being a summer 2019 model, but realistically this is roughly the best APU that you can technically buy on the AMD side of things, because the 4000G series never really existed to DIY buyers. So it'll be interesting to see the improvements that AMD has made from Zen Plus and the old Vega 11 chip up to Zen 3 with the newer, different Vega 8 chip. Just as a note for the Ryzen 5 3400G, our memory was run at 3200 MHz for this testing because the chip just couldn't support 3600 MHz. As always, more details on the test system and procedure over on the KitGuru website. In terms of clock speed, the Ryzen 7 5700G typically run at about 4.375 GHz and 88 watts of package power under a stock CPU-only all-core load. The maximum boost clock that we actually observed was 4650 MHz, which is just above the rated frequency as is typical for Zen 3. And when looking at GPU-only clocks, the integrated Vega 8 chip would remain at 2 GHz flat when not having any power diverted to the CPU cores. When we did run Cinebench on the CPU and 3D Mark on the iGPU, so they had to shave that 88 watts of power as is dictated by the 65 watt TDP, we actually saw that the GPU would hover around 1.5 GHz on its cores and the CPU would drop to around 4.2 GHz. What this meant is that we were clearly power limited at stock, so there was plenty of opportunity to open up the shackles and remove them with Precision Boost Overdrive. That's exactly what we did. So when we look at the CPU only clocks, that would now run at 4.43 GHz under heavy load, so it was a modest increase, and it increased the power draw to about 100 watts or so on a CPU only load. Where we got real benefits from Precision Boost Overdrive though was CPU plus iGPU load-in, and we saw a sustained package power of around about 120 watts under the PBO situation for Cinebench plus 3D Mark simultaneously, and the GPU now maintained 2 GHz flat, whilst the CPU ran at 4.43 GHz all-core at the same time. So that really is a good upgrade if you can cool 120 watts of package power. And then just to do a little bit more messing around, we tried a manual OC and also fancier Precision Boost Overdrive settings. So on the iGPU, we did actually push the GPU cores to 2.3 GHz as set in the UEFI, and this was actually pretty much stable for our stress testing using 3D Mark, and it actually delivered a roughly 7% performance gain for the 3D Mark TimeSpy graphics score. So that was certainly not bad at all. 2.4 GHz was a step too far. We also messed around with the manual Precision Boost Overdrive adjustments. So this allowed us to push the GPU cores to 2.2 GHz using the maximum offset that we can apply, which is plus 200 MHz. So they still did have more headroom, but we couldn't use PBO in that situation to get more than the plus 200 MHz. So I guess if we summarize that, we can say that there's actually a pretty decent amount of headroom and tinkering ability in this Ryzen 7 5700G according to our testing. So whether you want manual OC, messing around with precision boost overdrive, basic precision boost overdrive, there's quite a few bits of tweaking that you can do to extract some more performance. So that's quite enjoyable. If we now look at our performance results with the Ryzen 7 5700G, let's start out with Cinebench R20 NT. The 5700G comes in very slightly behind the Core i7 11700K and around 8.5% below the Ryzen 7 5800X. AMD's APU does offer a 24% performance jump versus the cheaper non-APU 5600X though. The newer R23 performance hierarchy is basically the same as with the shorter R20 run, and the performance loss for the 5700G after 10 minutes of Cinebench R23 NT loading is non-existent, so that's a strong positive for clock speed stability. 1T scoring of 588 points again puts the 5700G behind the higher clocked 11700K and 5800X. This time, however, the Ryzen 5 5600X also overtakes AMD's Zen 3 APU thanks to that 6-core CPU's better boost clock proficiency and greater cache capacity. Once again, we see a drastic improvement for the 5700G versus the old 3400G APU. Blender's long classroom test shows much of the same as we saw from Cinebench NT. The 5700G is very slightly behind the Core i7 11700K, while the Ryzen 7 5800X with its higher power budget is notably quicker. AMD's 8-core APU does keep the 5600X at bay though, and the performance improvement versus the 3400G is once again gargantuan. The Core i7 11700K enjoys a slightly widened lead versus the Ryzen 7 5700G in our Handbrake H.264 test. AMD's own Ryzen 7 5800X is 14.5% faster than the 5700G, thanks in large to its 32MB L3 cache slab. The 5700G is notably quicker than both Ryzen 5 chips though. We see more of the same in the H.265 Handbrake test, but this time the 5800X lead over the 5700G shrinks to 12%. 7-zip decompression loves Zen 3, and this allows the 5700G to take its first victory versus the Core i7 11700K in our testing. A solid 20% performance boost is seen for AMD's Ryzen 7 5700G versus the 5600X CPU. In the 7-zip compression workload though, normal order is resumed, with the 11700K very slightly ahead of the 5700G, and the Ryzen 7 5800X even further ahead. The monolithic die Ryzen 7 5700G does not suffer with the half-speed write penalty of single CCX Zen 2 and Zen 3 desktop chips. And in terms of memory latency, the 5700G was not up to the Zen 3 desktop CPU standard, which is a little surprising. To summarize the CPU-focused performance thus far, the 5700G is a little slower than the 11700K, and is notably slower than the 5800X. However, the Zen 3 APU maintains a lead over the Ryzen 5 5600X in general, and it is much, much faster than the old Ryzen 5 3400G. Moving on to iGPU gaming. Now we know that esports titles and some less demanding games will be perfectly playable on this caliber of integrated graphics hardware, but realistically we want to give a more stressful test. So we're going to use some AAA titles, some old and really popular, some a little bit more modern, and some that we've just used for a long time and really do understand the engine quite well. F1 2020 can be cranked up to the medium preset at 1080p and runs surprisingly well on the Ryzen 7 5700G. AMD's new chip is notably faster than the old Ryzen 5 3400G, and the Core i7 11700K is absolutely nowhere to be seen. Godfall was not so successful at 1080p, even with its low IQ preset. The 5700G is 15% faster than the 3400G, which is not great for a 2-year newer chip to be honest, but none of the solutions were enjoyable here. We tried FSR to obtain higher FPS at 1080p, but the only FSR setting that we were happy with was the most demanding ultra quality preset. All of the other presets delivered atrocious image quality results. This did deliver a noticeable boost to the 5700G and helped it comfortably past the 30 FPS mark that may, at a push, be tolerable for some casual gamers. GTA 5 is old but still massively popular, so makes perfect sense for inclusion here. The 5700G does a good job at delivering an enjoyable gaming experience at 1920 by 1080. The average FPS number is above 60 FPS even with high IQ settings, and the 1% lows of 46 FPS are more than tolerable, especially with an adaptive sync type display. Here, the 5700G's performance uplift versus the 3400G is 19%, and the new AMD APU is more than twice as fast as the Core i7 11700K with its UHD 750 iGPU. Shadow of the Tomb Raider at its lowest settings and 1920 by 1080p resolution was playable and reasonably smooth on the 5700G. No, we couldn't hit the 60 FPS sweet spot, but for gamers who just casually play a title such as this with a 5700G now and then, the 19% lift to performance versus the 3400G will be welcomed. And now a less demanding game such as World of Tanks runs fine on the Ryzen 7 APU, with just under 100 FPS average at 1080p medium. A 22% performance boost is seen for the 5700G versus the 3400G, which, once again, is solid but is hardly groundbreaking for a 2-year newer chip. And Intel's Core i7 11700K once again was not playable in this title. Summarising the iGPU gaming, the Ryzen 7 5700G delivers a notable gain in performance versus the Ryzen 5 3400G, often to the tune of around about 15 to 20%. While that is respectable, it's hardly awe-inspiring for a 2021 APU versus a 2019 APU, and that perhaps highlights the limitation of using the same old Vega GPU architecture, irrelevant of the change to CU count and core clock speed for the GPU cores. Looking at Intel's Core i7 11700K iGPU, that is simply no match whatsoever for the integrated graphics on the Ryzen 7 5700G. The AMD chip is leagues and leagues ahead in terms of gaming graphics performance. We're now going to include some gaming numbers with our usual RTX 3080 dedicated GPU. These comparisons versus the go-to desktop chips show how proficient the Ryzen 7 5700G is as a gaming CPU if you decide to switch or upgrade graphics hardware in the future, or maybe if you just borrow an RTX 3080 from your friend for a weekend, because everybody needs friends like that. There's nothing wrong with buying an APU and using it with a DGPU sporadically, or if you can afford to upgrade in the future. With that said, our discrete GPU gaming tests with an RTX 3080 show that there are better gaming CPUs for the price than the Ryzen 7 5700G. We struggle to see a reasonable justification for buying the 5700G to use with a dedicated graphics card straight away versus just getting something like a Ryzen 5 5600X. But that's kind of obvious, given the resources and cost allocation of the onboard graphics for the Ryzen 7 APU. The Ryzen 7 5700G uses its full complement of 88 watts of package power, as dictated by the 65 watt TDP rating. This is easy to cool in a small form factor installation, especially when compared to the Intel Core i7, but AMD's APU also leaves more performance and frequency headroom to extract via Precision Boost Overdrive, or even manual overclocking if you prefer. Using our 280mm liquid cooler, there were no cooling concerns with the Ryzen 7 5700G. The bundled race stealth cooler will likely be fine, if not ideal, because the Precision Boost 2 algorithm will just reduce the frequency and power usage if it detects temperature levels getting a little bit higher than is tolerable. I think we've summarised most of the points that we want to highlight with the Ryzen 7 5700G throughout this review, but I guess we can quickly recap here. In terms of CPU performance, the Ryzen 7 5700G is a little bit slower than the Core i7 11700K in terms of compute performance, but given the price difference of about £30 to £40, that really isn't a bad result at all. That's actually quite a good result from the Zen 3 APU. What we do see though is that the Ryzen 7 5800X with its fully fledged desktop Zen 3 cores, that is notably faster across the board pretty much. So clearly that 16 megs reduction in L3 cache and the more restricted TDP on the Ryzen 7 APU does have a performance negative attached to it. And versus the Ryzen 5 5600X, what we typically see is the 5700G is faster in multi-threaded heavy workloads. I guess what we can say here is that the extra 2 cores for the 5700G more than offset the doubled L3 cache that the 5600X contains. And then on the GPU performance side of things, this is actually where the 5700G pretty much shines, to be honest. Reasonable 1080p gaming experience is actually achievable, even with some AAA titles with sensible image quality settings. The AMD chip is vastly superior to the Intel Core i7 11700K, and by extension it's pretty much faster than any Intel chip offered with an iGPU, so that is a strong positive there. And the performance uplift for the new Ryzen 7 APU is typically to the tune of 15 to 20% in games versus the Ryzen 5 3400G. At this point, I'm going to go ahead and say it, and if you disagree with what I'm saying, then certainly let us know in the comment section down below. But personally, I'm actually quite disappointed to see that AMD has somewhat slowed the progress of the GPU core side of things in the APUs. We're still on the same old Vega architecture that we've had for a long time on the Ryzen APUs, and that's disappointing to see. Yes, I know the CU count has changed, and yes, I know the clock speeds are higher and the process has been refined, but it's still Vega. Where's RDNA? Where's RDNA 2? You get those on the console APUs, why not on the desktop APUs? Now obviously there are defined cases for an APU if you want a truly small form factor system that is capable of some degree of decent gaming on a large screen TV or a high refresh rate monitor in a NUC size chassis. You can do that with this APU, and that's not something you can say about the competing Intel chips, and it's not something you can say about the APUs that come before the Ryzen 7 5700G to such an extent. And then another strong use case for a high-performance APU like this from a personal perspective is for home server application. 16 threads are great for carving up for VMs and Docker, and then also you get integrated graphics so that you can have that output, which is critical for a server, and you don't have to use up your probably single PCIe slot in your mini ITX system. So there are some clear use cases where an APU makes sense, but realistically, as we've already seen, if you're just going to be playing games and you want to spend about £310, £320, then this is not the best option. Something like a Core i5 at about 140, 150 or so pounds, plus a 170 pound GPU, which these days is something like a GTX 1050 Ti, that will deliver a better gaming experience. You have to have an APU use case for this to functionally make sense. So I think if we round this one out then, it is certainly good to see AMD finally offering a high-performance competitive APU to DIY system builders once again. The whole Ryzen 4000G strategy of going OEM only was just bizarre to me. The only thing I wish here is that we've been treated to the latest and greatest in graphics architecture rather than good old Vega. Perhaps that's me being greedy, but we've seen what RDNA 2 can do on the console side of things. That's what I want here, and that's not what we're getting. But anyway, as far as CPUs with integrated graphics go, the Ryzen 7 5700G is far superior to anything that Intel is offering in the consumer space, especially at this price point. AMD's APU really does excel in the realms of balance between CPU and integrated GPU performance, and it now is the de facto option for users with a genuine APU use case who want a high performance option. So I've been Luke Hill for Kick-Guru. Thank you for watching our video review of the Ryzen 7 5700G APU. Let us know what you think in the comments section down below. Is this the type of chip that you'd actually be interested in, maybe as a stopgap solution, maybe for your home server or your HTPC that you game on every now and then? Or do you just need a little bit more in the terms of graphics performance? Let us know in the comments section. As always, if you like this video, give us a like, subscribe, join the Kick-Guru channel on YouTube as a member. Please do check out the Kick-Guru website, that really helps us out and you can see more details over there. If you want to support us even more, buy a cool t-shirt like this one, interact with us on Discord and Patreon and the likes, and I will catch you in the next one.